So we're going to talk a little bit about the testing and the engineering that has gone into this product. We've been working actually on the engineering for about 6 years in refining this J-Edge anchor system. So the testing that we performed at KU Engineering Lab consists of 2 different types of tests. One is a tension test, and then the other is a shear test, and we've done 2 sets of shear tests associated with this. In this picture you can kind of see the shear test taking effect, and so we use kind of a jack hydraulic system to control the shear that's associated with the test. Looking at the tension testing, whenever they did the tension testing, all they did was they pulled on an anchor inside of the J-Edge system to try to find out at what loads does it actually fail. They were actually able to take it up to loads that were close to 28,000 pounds, and so our average curtain wall loads that we would have in tension are about 1,000 pounds per clip angle that's attached on. You can kind of see that in the chart that we have plotted over there, there's a very straight line that goes forward, and so we get well beneath with the 1,000 pounds where those loads were. We've actually done 2 shear testings out at KU laboratories associated with J-Edge anchor system, where we apply a simulated dead load perpendicular to the J-Edge anchor, and we're actually able to get up to about 20,000 pounds in each of those, where the testing actually became unsafe because there was an inclination of the angle with the hydraulic that just became unsafe. So it actually never failed the product. We can see though in the curves that were developed that it did somewhere in there maybe start to yield something associated with the assembly, but we have a very straight line that we can project forward to about 12,500 pounds. And so we can see that we're well below that in a curtain wall. What we would typically have on one dead load clip would be about a 400-pound load associated with that. So we're we're way down here in the loads associated with the capacity of J-Edge anchor system. Engineering, we've done multiple finite element analysis of J-Edge anchor system. We've had all kinds of different loads applied to it, different spacings of the bolts associated with the clip angles. We've had different vertical loads associated with it. This is some of the maximums that we kind of ran associated with it, where we had a 4,000 pound wind load simulated and about a 2,000 pound weight. This would be probably at the very high end of anything that we would ever see in terms of curtain wall construction associated with that. And so this 4,000 pound load that I'm talking about here actually gets divided out into 2 for 2 clip angles, and this 2,000 pound load gets divided out into 1,000 pound per clip angle. And we also ran some tension tests associated with it just to see what the tension would do just separate from these loads. And so we got all kinds of different good results associated with it, showing that the J-Edge anchor system is under yield and allowable stresses. Remember, we have a higher yield stress associated with this extruded part of 60 KSI plus, and also we can kind of see for the tension loads we're well underneath yield and allowable stresses. So we've done a lot of playing with the tested data and all the engineering data that we have, and we've come up with some interaction load tables that will soon be available on the website jedgeanchor.com, where we can actually plug in what are our dead loads and what are our wind loads and where do we play out with the tested data, also including an important safety factor on the tested data so that we know that we're well below allowable loads.